Hi guys, let's pick up with 10.4 inscribed angles. Okay, so let's take a look at our picture here. This is corollary 2. So what we have is a picture of an angle inscribed in a semicircle is a right angle. So let's take a look and see what this corollary really means. If we take a look, there is an inscribed angle in this picture. If I trace over angle ABC, that is our inscribed angle. So I'm going to extend it a little bit. So the inscribed angle, remember, has an intercepted arc. This is the intercepted arc. Notice what makes this picture different, though, is there is a diameter drawn. All right, if we have a diameter, we know that that cuts the circle in half. And if there's 360 degrees inside of a circle, half of the circle is 180 degrees. Now we learned yesterday that an inscribed angle is half of its intercepted arc. So if this is 180 degrees, this angle is half, which is 90. So 180 divided by 2 gives us 90. So basically, when you see a triangle drawn inside of a circle where one of the sides is a diameter, that angle right across from it will always be 90 degrees. So let's write down that angle B equals 90 degrees. So let's take a look here at some examples. So we have a picture that looks just like this. I notice in my picture here, I'm going to highlight in orange that I have a diameter. Just like over here, I had my diameter. So in this picture, the angle that's across from the diameter is 90 degrees. So it wants us to figure out what x is. Well, I know that all three angles inside of my triangle have to add up to 180 degrees. So if I add them all up and set them equal to 180, I'll figure out what x is. So I'm going to start up top here. So let's do x plus 12 plus x plus 90 equals 180. All right, so we've got 2x. 90 and 12 is 102 equals 180. Subtract 102. We get 2x equals 78. Divide by 2, and we get x equals 39. So x equals 39. Now they want to figure out what angle W is. Well, we know that x is 39, we just plug it in. So I'm going to replace the x with 39 plus 12 equals 51. So angle W equals 51 degrees. We're going to do the same thing over here with 12 and 13. I have a picture. I have a triangle inside of my circle. I see that I have a diameter. So then I know that angle S is my inscribed angle. The angle across from that diameter is 90 degrees. So I'm going to do exactly what I did over here. Add up the angles and set them equal to 180. So we start with 2x plus 4x minus 6 plus 90 equals 180. All right, so 2x and 4x is 6x. Now we have negative 6 plus 90 is 84 equals 180. Subtract 84, and we have 180 minus 84 is 96. Divide by 6, and x equals 16. Now, they want to know the measure of angle T. Well, we're just going to plug it in. 4 times 16 minus 6. 4 times 16 is 64. Minus 6 is 58. So angle T is 58 degrees. All right, so now let's take a look at corollary 3. So corollary 3 is a little bit different. We don't have a triangle inside of our circle. We have a quadrilateral. So corollary 3 says if a quadrilateral is inscribed in a circle, so it's inscribed meaning all the vertices touch the circle, then its opposite angles are supplementary. So if we have a quadrilateral that all 4 corners are touching the circle, the opposite angles add up to 180. Opposite angles add up to 180. So angle D and angle F, they add up to 180. Angle D plus angle F equal 180 degrees. Meanwhile, angle E and angle G add up to 180. All right, so now when we set these up, all we have to do is look at the pair that are across from each other and add them up and set them equal to 180. So let's take a look at 14 and 15. They want to know the measure of angle R. Well, here's angle R. What's opposite of angle R? Angle P. So we add them up and set them equal to 180. So 3x plus 75 equals 180. Subtract 75. 3x equals 105. Divide by 3. And x equals 35. Now, angle S, same process. Here's angle S, 2x. What is opposite? The 110. So add them up. 2x plus 110 equals 180. Subtract 110. 110. 2x, that should be, let me make that look a little clearer. Subtract the 110. And we get 70, divide by 2, and we get 35. All right, so for 16 and 17, I'm just going to set them up for you. I think corollary 3 is actually like a fairly easy one. So let's take a look at 16. Angle W is right here, x plus 18. Across from it is angle Y. So for 16, we'd be doing x plus 18 plus 2x equals 180, and you guys can go ahead and solve. And then for 17, x and z, we have 3y minus 7 plus 3y plus 1 equals 180. You know what I just noticed over here? We forgot to do something. They want to know the measure of angle R and the measure of angle S. So let's go back and plug things in real quick. The measure of angle R, so let's plug in 3 times 35. And we get 105 degrees for angle R. That's our real answer. For angle S, 2 times 35. And we get 70 degrees for angle S. So don't forget to plug back in. I'm going to write a little note there. Plug back in. Because you can see how easily you can forget, because I kind of forgot to do that. All right. All right, last theorem. So this theorem's not too hard. It just kind of looks like a different kind of picture, because everything that we've had before, everything has been inside of the circle. But in this one, it looks like an inscribed angle, all right? And it is, but one of the sides come outside of the circle. So theorem 2 says the measure of an angle formed by a chord, so this is our chord, and a tangent, this is our tangent, is equal to half the measure of the intercepted arc. So it's like our inscribed angle where the angle is half the measure of the arc. So angle T is half the measure of arc AT. So in this picture, if AT, so if that arc was 140 degrees, if that arc is 140 degrees, in order to figure out what angle T is, all we have to do is 140 divided by 2, and it's 70 degrees. So let's take a look. For angle 3, we're going to do just what we did over here. 198 divided by 2 gives us 99 degrees for angle 3. Now let's take a look at number 19. Number 19, we have to do one more little step because angle 4 goes with the intercepted arc, which is right here. But we don't know how much that is, but we can figure it out. Aren't there 360 degrees inside of every circle? There are, so we know that this guy right here is 124. So if we do 360 minus 124, we get 236 for this orange arc. Now this angle is not 236 degrees, which I know some of us might put down. What I did over here was I had to take half. I had to take half. So 236 divided by 2 is 118 degrees. So angle 4 is 118 degrees.